Good morning, everyone, and welcome to this webinar. This is first of a series of webinars that we have planned over the next few months on the topic of fleet electrification challenges and opportunities. Electrification is and will remain #1 challenge for the fleet managers for foreseeable future. After speaking with the fleet managers, we are finding out that they are still unsure of the best approach to take on the journey to net zero, with some real concerns around the investment costs, vehicle choices, charging infrastructure, battery technology, and operational impact. And why do we worry about it? Because we provide end-to-end solution in commercial fleet electrification. We are Hitachi ZeroCarbon. Our mission is to expedite the accelerate the electrification and sustainability, reduce risk and total cost of ownership, and help generate new revenue streams for our customers and partners alike. We have spoken with and worked with our global customers and partners, and we understand the challenges they face when they begin their transitioning of the fleet to electric. Through those understanding and our learning from Optimise Prime, which is the world's largest commercial electric fleet trial, we have developed 4 core areas of offerings: zero carbon strategy, zero carbon charge, zero carbon battery, and zero carbon site. These help us charge your commercial fleet, finance your batteries, make those batteries last longer, help decarbonize your site, and most importantly, provide assured long-term performance through digital optimization. And that's what we have brought today to you. My name is Manish Kumar. I'm head of business development at Hitachi ZeroCarbon. And we are going to talk about the fleet electrification strategy and charging optimization. Along with me today is Jim Donaldson, who is our Chief Technology Officer. Jim has over 15 years of experience delivering IoT, AI, and big data solutions in security, software, and energy systems, and holds 15 patents. Prior to Hitachi, Jim spent 10 years as CTO of Oxford University spin-out company, developing cloud-based AI-driven energy management systems for domestic households, with a focus on specifically on reducing energy and carbon consumption at homes. As CTO for ZeroCarbon, Jim brings together Hitachi's technologies in AI and IoT to deliver solutions in energy, transport, and smart cities. Jim is a chartered engineer and holds first-class MEng degree in engineering sciences from Oxford University. Also today with me is Hugo Seymour, who is our head of customer strategy. Hugo joined Hitachi in 2019 to work on the Optimise Prime project, where he was responsible for designing and managing the trials run on over 8,000 British Gas, Royal Mail, and Uber vehicles. Building on the knowledge generated in that project, he now leads customer strategy team at ZeroCarbon, which supports fleets to capitalize on the opportunities presented by the switch to electric vehicles and low carbon power. Hugo comes from a background in strategy consulting and software startups, with a particular focus on using the technology to address sustainability challenges. Before I hand it over to Hugo, there are a couple of logistics points here. So this is a recorded session. And also this session is quite interactive, so please feel free whenever you have questions to put it on the chat box, which is on the top of your screen. So without further ado, I will hand it over to Hugo to dive deeper in the webinar.
Thanks, Manish. Good morning, everyone. I'm Hugo Seymour, and as Manish said, I'm head of customer strategy for Hitachi ZeroCarbon. I'm going to talk a bit this morning about the lessons we've learned from our work helping fleets to switch to electric. And essentially, there are 2 main questions that we find fleet operators are asking. Firstly, how will electrification affect my operations? And secondly, what will it cost? I'm going to explore both of those questions, and I'll also give you an illustration of how we approached answering them for one of our customers. So looking at how electrification affects operations, first of all, this can be broken down into 3 sub-questions that you see on the screen now. Firstly, the first consideration is, where does my fleet go? So how far do the vehicles travel per day? When and where do they stop? And how long for? at each location. This leads to a second related question, which is how much energy will they need? And that's a function of how far they travel, but it's also a function of factors such as vehicle type, the load that they're carrying, the topography of the route, and things like temperature control for the load also. Finally, once the energy requirement is understood, fleets need to know if they can access that energy without too much disruption to their standard operations. I'm going to look at each of those points in turn, and I'll draw on examples from my work in the Optimise Prime project and with customers beyond that as well. So to answer the first question, we look at fleet movement data from the existing conventional vehicle fleet. This can be quite complex for large fleets with reactive operations, and for those fleets, we ideally use a large data set taken from vehicle telematics systems to build up a statistical view of typical operations. And that would give you a picture like you see in the top two charts. So the left-hand side chart shows movements from a UK-wide maintenance fleet. So it's a little bit difficult to see, but that is a picture of the UK, and the red lines show the sort of density of operations for that fleet across the UK taken from telematics. The right-hand side is from Uber's movements database, and that shows, again, density of where their taxi drivers in London travel. And that was the basis that we used to calculate their likely charging behaviour in the Optimise Prime project. It isn't always necessary, however, for fleets with more predictable operations, such as with Royal Mail, who is also a partner in Optimise Prime, where the vans generally follow a more predefined route. Then you can build up a reasonable picture from their schedule, which is an example shown in the bottom right here. And for this example, which is taken from the Mount Pleasant depot in London, they have two schedules that operate morning to evening, one that operates morning only and one that operates evening only. An important thing to note here, I don't know if you can see it because it's quite small, but the important thing is that most of the vehicles from the majority of the shifts return by about 6 p.m. And with unmanaged charging, they would plug in and start charging in the early evening, and that would be a typical behaviour. In either case, whether we use telematics or schedules, we can work out the distances and the timing of the operations, and we can compare that to expected performance for an equivalent electric vehicle. That shows the extent to which an EV is a like-for-like replacement for existing vehicles, and it will also highlight areas where changes to operations might be needed, for example, to accommodate en-route charging for the longest routes. This analysis also provides the basis to estimate energy requirements for an electric fleet. Using distance and timing data from the operations analysis, together with data on typical performance for an equivalent electric vehicle, we can calculate energy required across the fleet. The fleet's operational timing enables us to convert that energy need into power demands at different locations and at different times of day to provide the charging for those vehicles. Chart on the left on this slide shows the resulting power demand at the same Royal Mail depot, whose schedules we looked at earlier. As you can see, there's a large peak in the early evening, which corresponds to the time when most vehicles return from their shift and start charging. You can also see an opportunity. There's almost no power demand during the night when the electricity is cheapest, and that highlights the potential benefit from smart charging to shift the load from early evening to overnight. I'll come back to that later, and I think Jim will dive into that in a bit more depth during his part of the presentation. Vehicle movements is not the whole story, though. The vehicle efficiency is going to vary depending on quite a lot of factors, including load, but also driving style, weather conditions, and season. And just to illustrate that point, on the right-hand side, the chart there shows how closely correlated the external temperature and energy consumption per kilometre are. This data is taken from Centrica's British Gas fleet from the Optimise Prime project as well. And overall, their vans require 30% more energy per kilometre in winter than they did in summer, which was actually quite similar to what we saw with Royal Mail vans also. The final operational question is whether fleets can access the energy they need to fulfil their operations. And to answer that depends on the type of operational setup and also the specifics of the locations in question. For depot-based fleets such as Royal Mail, the limiting factor is generally whether they can access enough grid connection capacity from the electricity network to satisfy the power demand. The chart at the top left shows available capacity at electricity substations across London, again taken from Optimise Prime. And you can see there's quite a lot of green showing areas where there may be capacity available for new connections or to increase connection capacity. But you can also see quite a lot of red locations where there's less capacity on the network available, and it could be more costly and, importantly, more time consuming to get the required connection capacity at that site. Other fleets operate different models, so not depot based. For example, British Gas operate on a return to home model, where the vans go back to the driver's home at the end of the day. Often people assume that this will be more straightforward to electrify because you can simply install charge points at the drivers' homes. And that was Centrica's assumption when they started on their electrification journey. And it did work well to start off with because they could prioritize drivers with suitable home locations. And at the beginning of Optimise Prime, nearly 90% of their electric van drivers charged exclusively at home. That decreased year on year as they increased the size of their electric fleet, as you can see in the chart bottom left. And in fact, Centrica expect just 40% of their fleet to charge at home by 2030, as the majority of their drivers don't have off-street parking, or they may not have a suitable electrical configuration, even if they do have off-street parking. These drivers then need to find somewhere else to charge, which leads to public charging or use of public charging infrastructure. There's also some issues with that, however. The charts at the top right show model demand for charging from Uber drivers at their two most favoured locations in London, taken from the modelling work we did in Optimise Prime. It's probably a little bit difficult to see from the charts, but essentially this is showing that at peak times, those charge points would be overutilised, meaning that the drivers would either have to queue and wait to use the charge point, or they'd have to sort of continue to somewhere else to the next available charge point, adding extra distance onto their route to find an available charger. And then when they arrive at that charge point, it can also be difficult to predict whether charging is going to be successful. I've taken a few screen grabs from driver comments in the ZapMap app, illustrating some of the issues that people encounter when using public charge points. So they can be out of service at the time when they're wanted, or they might all be busy. So you'd have to wait for a charging event to finish at the time that it's needed to charge for the fleet. And that can be quite disruptive for a commercial fleet, disrupting drivers' ability to complete their scheduled jobs for the day if they're spending an hour or more waiting for a charge point to become available. And the cost can vary significantly across public charge points depending on the network and the speed of the charge as well. And that brings us to the second main question of what electrification will cost. Again, that can be broken down into three sub-questions. So firstly, what's the upfront investment required to get started? Secondly, what's the ongoing operational cost? And then is it possible to generate any new revenues from this investment in new electric vehicle technology? Overall, fleet operators want to understand, is my investment going to pay back, or do I need to factor in an increase in my fleet budget? So looking at the first question, first of all, upfront cost is typically made up of four contributing factors. So firstly, the vehicle and the battery itself in particular. This can be substantially more than an equivalent diesel vehicle. As an example, due to the large battery size, the capital cost of an electric HGV can be up to 200% more than a diesel one. Then the grid connection cost, as we saw with the earlier example, depending on the location and the power required, it can be quite a significant cost. And importantly, there can be a long lead time to get the increase in capacity. We looked at several Royal Mail depots during Optimise Prime, and we found the connection costs of up to £200,000 per site. And that's just looking at the van fleets. This could be substantially more for higher power demand for larger vehicles, such as HGVs or buses. But also lead times were up to 52 weeks in some cases, which can be a big disruption to plans to electrify the fleet. Then there's the charge points themselves. These can be quite costly if required at large volumes or if you need high power. But there's also all of the civil and electrical works to consider, which adds additional complexity and cost. Finally, there's often people costs involved in electrification in terms of training your workforce and potentially hiring new people with specific skills required for electric vehicle fleets. That can all be quite daunting, but there are opportunities to mitigate all of those cost factors. So firstly, on the vehicle and battery costs, these can be paid as a lease rather than upfront, and that has the added benefit of transferring some of the technology risk of these new technologies to a third party. Use of smart charging optimization can reduce the peaks in power demand, meaning a lower request to the grid to upgrade the capacity, and that would result in lower cost and also shorter lead times to get that connection in. Charge point costs can be reduced by planning for the end state. So if you want to eventually get to 100% EV, you should plan for that state from the beginning. Then you can put in the cabling that's required to support your full fleet, even if you're only going to put in charge points for the first, say, 10% to start with. But that avoids needing 2 sets of civil works to replace the cables when you electrify the rest of the fleet. Finally, on the people point, a lot of the new skill requirements can be avoided or reduced by working with specialist partners so that you don't need to in-house all of those new capabilities. The ongoing cost can actually be a good news story for EV. Electric vehicles are typically more efficient and require less maintenance than conventional vehicles. There can be quite a lot of variance in the main operating cost, though. Depending on the time of day when the fleet charges, the electricity cost can vary substantially, and having the right smart control can be really important to ensure that the charging costs are kept as low as possible. This chart shows some of the modelling of charging from Optimise Prime. It's quite complex, so I just want to highlight a couple of things from it. The green line along the bottom shows modelled power drawn to charge vehicles across a week of operations. And it's important to note that Royal Mail don't deliver on a Sunday, and also that their routes are quite short. So the model's taking this into account and front-loading charging for the week on Sunday. So you see a big peak during Sunday to fill up the batteries of all of the vehicles for the week. Then the yellow dashed line shows the electricity price, and that varies in 3 bands by time of day. And as you'll be able to see, hopefully, it's possible to provide enough energy to satisfy all of their fleet operations for the week. So we never get down to below sort of 20% state of charge across the vans. And that's possible only charging at times of day when the electricity is cheapest. And compared to their standard practice, which is to plug in and charge immediately when the vans return at around 6 p.m, that would equate to a saving of up to 60% on the electricity cost. And finally, there's the opportunity to generate new revenues from investment in infrastructure for an electric vehicle fleet. Firstly, we can sell demand flexibility to the electricity networks. And the chart on the left shows an example, again, from Optimise Prime, where we've turned down charging power between 5 and 7 p.m. in response to a request from the distribution network operator. And that resulted in a payment to Royal Mail for providing that service. The results from Optimise Prime indicate that about 20% of fleet charging costs could be covered by providing flexibility. And that's looking at today's market prices for flexibility. Demand for flexibility is expected to increase over time as we reach more and more renewables into the electricity mix. So the potential value for fleet operators could be higher than that in future. Secondly, there's the opportunities to share charging infrastructure. As we saw earlier, public charging can be challenging for commercial fleets, but as with the example from Centrica, they may not always have access to a suitable location of their own to install their own charge points. And conversely, depot charging fleets are likely to only be using their charge points for part of the day. So with Royal Mail, they're out doing deliveries during the day and charging overnight, but so their charge points are unused for most of the day. There's consequently an opportunity to share. And the images on the right-hand side show an example from work we're doing with First Bus in Glasgow to enable partner fleets to charge at their depot while their buses are out during the day. So DPD vans and Police Scotland vehicles are able to come into the depot and they pay First Bus a fee in return for charging at the bus high power rapid chargers. And that gives them certainty of charge that they wouldn't have at a public charge point. So they know that when they turn up at the depot, there will be a working charge point available for them to use. And that creates a new revenue stream for First Bus as well. So to summarize, there are a lot of things fleets need to consider when they're planning to electrify. And we work with fleet operators to help them understand all of these questions so they can move forward with confidence and at the right pace for them. So a few things on this slide, just to give an example of some work we did with a large UK fleet with about 3,000 vans. And again, similar to Centrica, they're home-based, so the vans return with the driver to the driver's home at the end of the day. And for similar reasons to the Centrica British Gas example, they needed to move away from their initial plan to install charge points at the drivers' homes, and they didn't want to rely on public charging due to the potential impact on number of jobs per day and lack of certainty around getting that charge. Excuse me. So we analysed 33 million rows of data from their existing fleet telematics system to build up a picture of the likely charging demand by location across the UK. And that's the images shown on the left-hand side of the slide. We also looked at the charging supply locations, including their own workplaces and warehouses, as well as possible partner sites, so things like First Bus depots, for example. And we looked at that in comparison with the driver home locations. That modelling created an expected power load profile across the fleet, which is shown on the top right, and specific demand by location as well. That showed us that the fleet could charge at their own facilities with minimal disruption to normal operations, so accommodating diversions of less than 2 miles from their optimal route, and with charging times that could fit into their typical stop times that they would have anyway. Overall, our modelling suggested this would provide about £80,000 per year of charging cost savings compared to using public charge points, and not taking into account the cost of disruption to operations that could result from public charging as well. As we've seen, with the right planning, electrification doesn't need to be high cost or daunting, but you do need the right tools to achieve those savings. And I'm going to hand over to Jim now to talk more about the tools and technology needed to make that happen.
Cool, that's brilliant. Thanks very much, Hugo. So, as Hugo said, now I'm going to talk a little bit about our tools and our software offerings that we can provide to you to enable this fleet transition. So just to start a little bit about our ethos and where we're coming from here. Our group comes from a energy background, and indeed, when you're talking about the EV transition, it is very much ultimately about an energy transition. You'll have very often heard people talk about EVs as batteries on wheels. You may have heard about the ideas of using them to provide energy back into the grid. You may have heard about how you can take advantage of the more complex tariff regimes, which are in the electricity space. You might look about how you integrate with renewables, deferred storage, these kind of ideas. And so very much there's a huge energy component to the EV transition. But when people talk about batteries on wheels, they often forget that the primary function of an EV is not an energy storage device. It is ultimately a transport device, and therefore it's got to fulfill its primary job of delivering parcels, delivering people to wherever they need to go. So we've designed our software and our ethos very much as the intersection between energy and transport. So being able to take advantage of all the benefits and the opportunities that you might get from starting to move into the electricity zero carbon space, but for remembering, of course, that you have to provide a reliable, predictable service to fulfill the existing operational requirements of those vehicles. So to do that, we've developed our zero carbon charge software, which I'll talk about on the next slide and give you a high level overview of some of the features. There's a lot of features that the software system provides, and I won't go into all of them in depth, though we can of course cover some more in the Q&A as well. But at a very high level, what we have is a software system which will enable you to effectively manage, run and optimize your EV fleets. a few sort of core features that we provide. Number one, real-time visualization of your EV and your fleet operations. It's amazing when you've got a large amount of vehicles across your estate, plugged in, charging. You need to have that visibility of what is the status, what is the state of charge of those vehicles? Are they charging as you expect them to charge? Are there any faults? Are they being plugged in correctly? Is the charge going to be completed on time? Will they have sufficient range for tomorrow's operations, etc., etc.? So the huge set of requirements and capabilities that the software needs in order for you to provide and manage that charging. So we do that. We also give functions to maximize the available maximize the available capacity that you have from your electricity system. If you have one or two EVs on site, likely you won't have any challenges. But as Hugo was talking about, you've got lots and lots of EVs on a site, you might start to run into constraints on your own private network in terms of the distribution or the breakers on site. You might start to run into constraints in terms of the supply into your site. So we provide tools to optimize that, to make sure that we're utilizing all of that available capacity you have, because any excess capacity is wasted. What you need to do, therefore, is spend money on upgrading. So we want to defer those upgrade costs as much as possible. We're schedule and logistics aware. So of course, you will have complex schedules when you're running your fleet. You might have existing yard management solutions or existing scheduling solutions. Our system needs to interface into those so that when we're optimizing and setting the schedules of your charging, that is aware of your schedule. So we're able to integrate into whatever existing digital tools that you have there. And then finally, Hugo gave an example of DPD, but we look at how we can enable future revenue streams. That might be, as Hugo said, through second, third-party charging. It might be by taking advantage of some of the benefits of participating in the energy markets or optimizing time of use. So these are all the kind of optimization ideas that we have. I'll talk about them last, because if we don't get the first three right, then you don't have reliable operations. So we focus on reliable operations, and then we start to move as to how you can increase your revenue, reduce your costs of running your EV operation. So to go into a little bit more detail on some of the slides, one of the key things that we found from our work with Optimise Prime, and indeed working with some of our other customers, is that no one facility is the same. Even for the same customer, two sites often end up being very, very different when we get into the details of how you might electrify. Typically, sites have got different electrical layouts, different electrical configurations, different age of infrastructure on the site. So we have to be network aware. We have to be able to take in those constraints, the potentially complex hierarchies that you have in terms of your electrical network, and we need to be able to balance across that. So our tools, our software is aware and able to optimize for different electrical configurations. We have to take into account the building loads. So on a site where there's vehicles, typically there's a very large energy consumption coming in from the on-site buildings as well, and that will vary over the course of the day. Typically, you might assume that the peak energy load is between 9 till 5, 8 till 6, something like that. But of course, it does depend on the function of the building. So there are many buildings which have got operations at night as well, and in some cases, the peak energy demand can actually take place overnight. And so we need to take that into account. We need to make sure that we're using all of that available capacity, despite the kind of varying energy consumption from other systems on the site, apart from just EVs. We need to take into account variable vehicle schedules. Hugo gave an example of where a lot of the vehicles are coming back and charging at 5 o'clock. But that is not guaranteed. And indeed, the graph in the middle there is quite small, shows the schedules again for a single customer across their different sites. So you can see that in some cases, the peak is very much vehicles starting to return at 5, 6 in the evening and starting to. Indeed, some of them are coming back at 3 o'clock, 2 o'clock, 1 o'clock even. So again, we're aware of these schedules. We're predicting when vehicles are going to come back. We're able to plan our charging appropriately and make sure that, again, all your operations are optimal. And then finally, from an energy perspective, on many sites, you might have different energy tariffs. You might have, some sites might have a flat energy tariff, whereas others might be on a half-hourly varying tariff. You might have renewable energy on some sites. So where based on the weather, you will have a different price of energy. So again, we take that into account through our software and use that into the planning, optimization, and charging scheduling. So I've talked quite a lot about the energy optimization side of things, but of course, core as well is the operational tools and systems that to enable you to manage and run the fleet. I pulled out 3 specific examples here. Again, there are others. Number 1, charging hardware agnostic. So our software system, whilst we work with preferred charge point providers, we're agnostic to the hardware, and we'll work with whatever hardware you might already have on site. That's important because you might be most people are not necessarily starting from zero. They might already have existing hardware deployed on site. And indeed, you might have multiple manufacturers depending on the use cases. Hugo talked about HGVs. You might have a different HGV charging to your LCVs. You might have high power, low power. You have a mix of DC, AC. So we're agnostic to that. We'll interface with everything and provide a single dashboard, a single system for you to manage across that charging hardware estate. We have a set of tools, dashboards, which give you fleet-centric and depot-centric views on what's going on. What do I mean by that? Fleet-centric, I mean that you can visualize and view the status of all your vehicles in real time by integrating into the telematics that you may have installed. So we can see where the vehicles are, whether they're in the depot on the road. We can see the status of the charge, and you can use that to pull together a single view of your fleet, how your fleet is performing from an energy perspective. But we also have a depot-centric view on the world, on the operations. So what is the current status of your depot from a charging perspective? How many chargers are charging? How many vehicles are plugged in? What's blocked, i.e. what vehicles are there plugged in but no longer charging because they've completed, which means they need to be moved? Are there any faults? Of course, hopefully your systems are very reliable, but every so often there might be a fault or something might not have been plugged in correctly. So we have a set of alerting and tools to allow you to monitor that. That's all around a set of views and dashboards to allow you to visualize your operations. And then finally, more of an offline kind of activity, but all the data that comes in from the vehicles and the charge points is stored and then made available for business reporting capabilities. So that allows you to view historically with our analysis tools how things are performing. What's the cost of running the fleet? What's the efficiency of the fleet? Has anything changed? Are there any opportunities for optimization? Should you change energy tariffs? These are all the kind of questions you might be asking. And again, we enable those either directly through the tool, in more advanced cases by being able to export that data and integrate it with other parts of your analytics or business intelligence activities on site. Finally, just as a specific example, I'll talk a little bit about the technology behind the second-party charging and the revenue opportunities. So Hugo talked about this at a high level. This is a great example of how we can very simply start to enable new opportunities for you, firstly on a trial basis, and then moving into business as usual. The enablement of the trial with DPD and First Group didn't require any additional technology deployment. In more advanced cases, you might start to look at access control systems, you might look at RFID cards, you might look at user authentication. But in this case, we were able to very simply enable it by simply whitelisting the vehicle IDs. So DPD submitted a set of vehicles which would be authorized to charge on site. When they come to the site, they plug in. There's an automatic authentication process that happens between the vehicle and the charging system. If that whitelisting is successful, the vehicle charges, and then through a very simple reconciliation process afterwards, we're able to look at the allocated charging that's happened to the DPD vehicles in this case, are able to generate the financial reports, the operational reports, and then enable a very simple invoicing process. So this is just a simple example of why, with a common extendable software system that we have in place, we're able to very quickly trial and roll out new functionalities that will help you to grow your business and look at new opportunities in line with your broader decarbonisation strategy. So I'll finish there. I'll hand back to Manish for a conclusion, but thank you very much for your time. Look forward to any questions.
Thanks, Jim. So great. So before we go into the takeaways, please feel free, if you have any questions, to put it in the Q&A button there rather than the chat box. So you will find it on the top of your screen next to apps. So based on all the discussion, so when we look at what are the key takeaways from the session, and we look at it in 3 ways. Number 1, start early and start with the proper planning. The strategy, the fleet electrification strategy has to be as holistic as possible. Remember, putting up a charge point in the ground and connecting the cable to the vehicle will not take anyone too far. It really, the fleet electrification strategy need to be the fleet operation centric rather than the charge point centric. The second point is around the technology. You need to look into deploying the technology that helps you avoid the upfront capex by right sizing. Keep your OpEx low through digital optimization and help you generate new revenue stream that Jim and Hugo talked about. And third and really important one is finding the right partner which provides you end-to-end solution in commercial fleet electrification, like Hitachi ZeroCarbon. So we will be managing your risk while you can focus on the work that you are really best at. So we will stop the presentation here and we will open for the Q&A session. Please feel free to keep flowing, to keep asking the question. And as I said, while the questions are coming, as I said, this is the first of this series of webinars. So we will be having other webinars getting planned in a month's time as well. The next one will be focusing around the battery monitoring. So stay tuned on that one as well, please. Let me see if there's any question here.
I think this is probably best for Hugo. It's from Stuart Ballantyne. Given the emission reduction targets placed on the public sector, are many local councils, housing associations and NHS authorities engaging with you to conduct any case studies?
Okay, thanks, Jim. And yeah, I think it's a great question. There is a lot of burden being put onto these sorts of public sector organisations to decarbonise their operations, and that includes their fleets. And the sort of analysis that we've covered today would be exactly the right starting point for them to understand what that's going to mean for them, but also so they could capitalise on potential opportunities. I think for those sorts of organisations, if we're thinking about the NHS or local councils, they've typically got quite a lot of real estate, so would have space that they could potentially open up to third parties to provide charging infrastructure similar to the first bus example. So I think there's a big opportunity for those fleets. From personal experience, I think they're having to deal with a lot of other priorities at the moment. So I don't know if this has got far enough up their agenda yet for them to be thinking about it in depth, but absolutely they should be, and we'd be very happy to work with them to support them on that journey.
Thanks, Hugo. There's another question coming. You mentioned 80K savings. What are the overall OpEx for this particular fleet operator?
So I think that's a question for me again. I don't have the specific numbers in terms of OpEx, but this was essentially comparing the cost of the electricity for public charging across the fleet with the alternative of installing their charge points into their own locations and then using their own business tariff to provide the energy for those charging events. So that can be quite a big differential, and the prices for public charging keep going up. So last time I checked, it was northwards of 70 pence per kilowatt hour for rapid charging. And if you think about the sort of requirements of a large fleet doing daily operations across the UK, that can be quite substantial compared to a typical business energy tariff. So that's what the differential is there. Importantly, there'd be other operational costs associated with public charging as well, which are not included in that £80,000 figure. So for example, moving from 10 jobs per day, for the sake of argument, down to 9 or possibly 8 if they need to take up lots of time during their working day to wait for the right public charge point to become available.
Well, thanks a lot, everybody, for joining and for your time today. I hope you found it really useful, really helpful. We are looking forward to have our next session around the battery monitoring. As we mentioned earlier, we will send out the invite again, look out for that. And thanks a lot again for your time this morning.